Okay, we are going to start Unit 8, which is all about factoring. Factoring is just taking what we did in Unit 7, what your test was over today, and working backwards. And so we've learned how to multiply and go forwards. Now we're going to learn how to factor and work our way backwards. So, definitions first. Most of these you probably know, but we're going to go over them again anyway, just to be sure. Factors. All right, factors are any number or expression that can be multiplied by another number expression or expression to create a product. For example, if I give you the number 6 and I say, tell me the factors of 6, well, the factors of 6 would be 1 times 6 because they multiply to equal 6, or 2 times 3 because those also multiply to equal 6. So the factors of something are things that multiply to equal that number. So, two other definitions. Prime number. A prime number is any whole number greater than 1 By greater than 1, I mean it can't be 0, it can't be 1, or it can't be negative. So it's got to be greater than 1 that has only 2 factors. Always those factors are 1 and the number itself. For example, the number 5 is prime because the only 2 numbers that multiply to equal the number 5 are 1 times 5. And so those are your whole number factors, 1 times 5, and so it only has 2, 1 and 5. That's it. There are no other whole numbers that will multiply to equal it. Composite number is any whole number that greater than 1 Notice they have to be whole. They can't be fractions or decimals. It has to be a whole number. Any whole number greater than 1 that has more than 2 factors. For example, the number 9 is composite because I can multiply 1 times 9 to get 9. I can also multiply 3 times 3. So it has more than 2 factors. It makes it composite. So our first 4 examples, all we have to do is determine if the number is prime, composite, or neither. So, and every number out there is either a prime number, a composite number, or it's neither one. So the number 36, well, the factors of 36 would be 1 times 36. We could do 2 times 18. We could do 3 times 12. We can do 4 times 9. And, of course, we can do 6 times 6. Well, that definitely has more than 2 factors. So 36 is a composite number. Now 61. The only 2 numbers I can think of that multiply to equal 61 are 1 and 61, which makes this a prime number. So number 3, negative 150. Number 1, it is not a number greater than 1. Because it is negative, it becomes less than 1. Negative numbers cannot be considered prime or composite because they don't meet the definition, so this is neither. And it's only neither because it is negative. It's still a whole number, but it is not greater than 1, so it does not meet our definition. Now number 4, I'm not going to list out all of the factors of 220, but I can come up with a few. 1 times 220 will give me 220. 2 times 110, well, magically, I already have more than 2 factors. I don't really need to go any further. This is a composite number. Now, if you want to list out more of the factors, more power to you, but that makes it composite because it has more than 2. Now here's our focus today, greatest common factor, which is an old concept to you. You probably learned, not probably, you did. You learned this in elementary school, 3rd, 4th, 5th grade, something like that. You learned how to find the GCF or greatest common factor. The greatest common factor is the largest factor a set of numbers has in common. And I'm going to show you one time how to find greatest common factor using a prime factor tree. And then that is the rest of the time, I'm just going to do it in my head. And I'm pretty sure most of you will be able to do the same thing. You'll probably be able to do them in your head, but I am going to show you. If you are still confused after that point on how to find the GCF or to get to the greatest common factor, there is another video in my feed, and it's called Mackenzie Teaches the GCF. You can go watch that video. It's 5 minutes. It is Mackenzie showing you how to find the greatest common factor. She does 2 examples. Like I said, it's 5 minutes. You can go watch that to, touch up. So 16 and 24, we're going to do it using factor trees. So to find the greatest common factor, first thing I do is draw a factor tree. So 16 can be factored out into 2 times 8. Well, 2 is prime, so there's no need to factor that anymore, but 8 can be factored into 4 times 2. Again, 2 is prime, but 4 can be factored into 2 times 2. I've gotten all my prime ones down. I can't factor anymore. So now let's do 24, same way. Factors of 24, 2 times 12. 2 is prime, but I can still factor 12 into 6 times 2, and I can still factor 6 into 3 times 2. Now I'm going to look and see what these 2 factor trees have in common, and I am only looking at prime numbers. So I'm looking at the numbers that do not have trees underneath them. Okay, so 16 has a 2, and so does 24. 16 has another 2, and so does 24. 16 has another 2, and so does 24. So they have 1, 2, 3 2's in common. So the greatest common factor for 16 and 24 is 2 times 2 times 2, because they have 3 3's in common. So the GCF for 16 and 24 is 8. That is the largest number that will go into both of those. So now for the rest of the time, I'm going to do in my head what the greatest common factor is. If you struggle with this, I suggest you find a method that works for you, draw the factor tree or whatever, so you can find the GCF. Number 6 has numbers and variables. And so I have to find the greatest common factor of both. We always do numbers first. So I have 15 and negative 20, but I'm going to ignore the negative for finding GCF. The greatest common factor of 15 and 20 is going to be 5. That's the biggest number that will go into both of them. Now for the variables, okay, y to the third means y times y times y, and then y squared just means y times y. Well, if I look to see what they have in common, they both have 2 y's in common. Well, so the rest of my GCF for this is going to be y times y, which is y squared. And so the greatest common factor for these 2 monomials is going to be 5y squared. Now, if you don't want to draw in expanded form every time, shortcut for remembering the variables. Look at the variables. I got y to the third and y squared. Y squared has the smallest exponent, therefore that is my GCF. The smallest exponent will always be your greatest common factor when it comes to the variables. So now look at number 7. Numbers first. I got 13 and 2. Well, 13 and 2 both happen to be prime. Therefore, the only thing they have in common is a 1. Now look at your variables. Q to the 4th and p squared. My 2 monomials don't have any variables in common, so the greatest common factor for these 2 is just 1. That's the only thing they have in common, is a 1. So let's do one of these that is pretty big. So let's look at number 10. Number 10 has 3 numbers, 60, 45, and 30. And I need the biggest number, the greatest common factor that will go into all 3. Well, it happens to be 15. 15 will go into 60. It will also go into 45. It will also go into 30. There is not a bigger number that will go into all 3. So now let's do variables. I have an r squared, an r to the third, and an r squared. The one with the smallest exponent is part of the GCF, so that's r squared. So now let's look at s's. I got s squared, no s's, and an s. Since all 3 terms do not have an s cannot be in your greatest common factor. All 3 things must share it. So no s. So let's deal with the t's. I got t squared, t to the third, t to the 4th. Well, the one with the smallest exponent happens to be t squared. So my greatest common factor is 15r, I'd like that to look like an r, squared, t squared. So now let's talk about how do we factor using the greatest common factor. We're going to do a couple of examples, and then we're going to talk about something called the grouping method. I'm going to do, and we'll talk about that. So our goal here when factoring is to break our monomial or our polynomial up into the 2 things that multiply to equal that. Just like if I were going to factor the number 15, well, 15 factors into 3 times 5, because 3 times 5 makes 15. Just in this case, I've got numbers and variables, so I'm going to have to deal with all of that. Here's what you do. Step 1, find the greatest common factor, 24, 56, and 8. The greatest common factor for all three of those numbers happens to be 8. Now let's do the variables. I've got a squared, a, and no a, so a does not become part of my GCF because they don't all three have one. And then I have x to the third, x squared, and x. Well, x is the smallest exponent, so that's my greatest common factor, 8x. This times something else will have to equal this number. So now it's just a matter of working backwards. I've got to figure out what goes in here that can multiply times 8 to give me what I started with. So it basically becomes a division problem. 24 divided by 8 gives me 3. So I'm working backwards. 8 times 3 makes 24. Now I've got to deal with variables. Here, the variables I think are pretty simple, but they can be confusing. So I have an a squared in my answer. I did not factor out any a's, so in my factor, I've got to include the a squared. My answer has x to the third, but I have factored out x to the first, so my other factor has to have x squared because I need 3 total. One of them is out here, so the other 2 have to be in here. 1 plus 2 makes 3, okay? Now put your minus sign because that's what's there. Now 56 divided by 8 is 7. Again, I have an a, but I didn't factor any out, so I've got to include the a as part of my answer. Now, x squared is in my answer, but I factored out 1x already, so I need 1x in my other factor, so that this x and this x makes x squared. Now, I have 8 divided by 8 makes 1. And then I have an x in my answer, and I already factored out that x, so I don't need any x's in my answer. That is the finished problem. This times this will equal what I started with if I multiply it. If I were to do the distributive property, this would be my answer. Okay, so these are the 2 factors of that polynomial. Let's try another one. So I have 35, 40, and 20. The greatest common factor for those 4 numbers is going to be 5. It is the largest number that will go into all 3. Now let's do variables. I've got a squared, a to the third, a to the fourth. A squared is the smallest, it's GCF. B to the third, b squared, well b squared is the smallest, GCF. C squared, c is the smallest, factor it out. Now it's working backwards. Well, 35 divided by 5 is 7. Then I deal with my exponents. I need a squared, I factored out a squared, I don't need any more a's. I need a b to the third, I have factored out b squared, so I still need 1b. I have a c, I factored out a c, I'm done. Plus sign. 40 divided by 5 happens to be 8. I need a to the third, I have factored out a squared, so I've got to have another a. B squared is my answer, I factored out b squared, I'm done with b's. C squared is my answer, I factored out 1c, so I need another c. 20 divided by 5 is 4. I need an a to the fourth, I've factored out an a squared, so I need 2 more a's because a squared and a squared, add your exponents, makes a to the fourth. I need a b squared, I have factored out b squared, no more b's. I need a c, I factored out a c, I'm done with c's. These are the 2 factors for that polynomial. So this is factoring with the GCF. Not every problem gets factored that way, however. Sometimes, if you look at numbers 13 through 15, you're given, I apologize, instead of 3 terms, I have 4 terms. And the first thing we are going to do is not pull out a GCF, because the GCF for number 13 here, I've got 7, 2, 28, and 8. The only thing that goes into all 3 of those numbers is a 1. Factoring out a 1 doesn't change anything. What I need to do is be able to factor this into the 2 things that multiply to equal it. So here's what we're going to do. We're going to do the grouping method. So I'm going to group these 2 together, and I'm going to group these 2 together. So now it's a matter of I'm going to factor. So let's take the first group. I'm going to pull out the greatest common factor just for this group. So the greatest common factor for 7 and 2 is going to be a 1. And then for x to the third and x squared is going to be x squared. So I'm factoring out an x squared. Now I'm going to do what I was doing in the last problem. 7 divided by 1 is going to be 7. X to the third, x squared, I still need an x here. Plus sign. 2 divided by 1 is 2. I factored out the x squared already, so I'm done. Put your plus sign. Now the greatest common factor for 28 and 8 is going to be 4. So the greatest number that goes into both of those is going to be 4. And since they don't both have an x, I will not factor out an x. So 28 divided by 4 is 7, and I still need the x, so I'm going to put it here. Then 8 divided by 4 is 2, and so there's my, I'm done. Now if you will look, the two things in parentheses that came out together, they happen to match. That's because one of my factors is going to be 7x plus 2. The other factor is what's left outside of the parentheses. So the other factor happens to be 1x squared plus 4. You only write down the 7x plus 2 once, even though it shows up twice. It shows up twice as an instant check. Oh yeah, okay, I'm done, it worked, they match. If they don't match, you've made a mistake. If they do match, that's one of your factors. So these two things, if I multiply them together, will give me this. So now let's do 14, and I'm going to do 14 a different way. I'm going to do 14 using the box method. When you factor, it is not going to matter to me whether you choose grouping or the box method because they both work. I just want you to see both of them. So here's how the box method works. We're going to fill all of this into here. 2d to the third goes in this top corner. Negative d squared goes here. The next one is going to be the 6d. It's got to go right here because we're going to go in order, d to the third, d squared, d to the first, and then no d. And so then the negative 3 goes here. So we always have to make sure we go in order. D to the third, d squared, d to the first, no d. Now we're going to do this GCF thing again, except we're going to do it row by row and column by column. So this row right here, the greatest common factor between 2 and negative 1 is going to have to be a 1. And then my d's, d to the third and d squared, I got to pull out a d squared. Now I know that's negative. We'll deal with it in a minute. Greatest common factor here between 6d and negative 3 is going to be 3. Now for this column, the greatest common factor for 2d to the third and 6d is going to be 2d. And then right here, now both of these are negative, which means my greatest common factor is also going to be negative because they both share a negative. Then I have 1d squared and 3. Well, that's just going to be a greatest common factor of 1. So what happened on the outside of my box here are my factors. My two factors are going to be d squared plus 3. That's this side of the box. And then 2d minus 1, which is the top part of the box. If I multiply these two things together, this would be my answer. So let's try one more. Okay, I'm going to do number 15. I have negative 9a squared plus 12a to the third minus 15 plus 20a. Now, like we had to do with the box, we need to write it in the correct order. A to the thirds, a squareds, a, then no a. So the 12a to the third comes first. The minus 9a squared comes second. The plus 20a is next. And then the minus 15. Now I'm going to do this one with grouping. Okay, so I'm going to group just like before. And now I'm going to do the greatest common factor. So the greatest common factor between 12 and 9 is going to be 3. And then for a to the third and a squared is a squared. So there's my GCF. Well, 12 divided by 3 is 4. A to the third, a squared, which means I still need an a. 9 divided by 3 is 3. I've already pulled out the a squared, so I'm done. Now the greatest common factor between 20 and negative 15 is going to be 5. They don't both have an a, so that's it. So now 20 divided by 5 is 4, and I got to keep the a. And 15 divided by 5 is 3. Now if you will notice, in parentheses, they match. One of my factors is 4a minus 3. The other factor is what's not in parentheses, which is 3a squared plus 5. So these two things would multiply to give me this. So we have now done three things. We found the greatest common factor of some polynomials and monomials. Then we went and we factored using the greatest common factor, and then we factored 4 terms using either the grouping or the box method, and I don't care which method you choose. This is what we'll practice tomorrow. I'm sorry that the video was so long. There was just a lot to show you. Have a good evening, and I will see you tomorrow.